Dear students, I am Professor Vasant Acharya and today we will discuss about a new topic of elements of electrical engineering, that is bipolar junction transistor. Now moving on to the topic, a BJT is a current controlled semiconductor device used for amplification and switching. तो ये BJT होता है बेसिकली इट इज ए करंट कंट्रोल डिवाइस एंड इट इज़ यूज फॉर एम्पलीफिकेशन पर्पस एंड स्विचिंग इन इलेक्ट्रॉनिक सर्किट्स. It has been invented in the year 1947 at Bell Labs. This BJT is made up of three doped semiconductor regions: emitter, base and collector. There are two types of bipolar junction transistor, NPN and PNP. Now coming on to construction, we have three layers: emitter, which is heavily doped, then base, it is thin but lightly doped, and collector, it is large and moderately doped. So if we have three layers, we can form two PN junctions. One is called as emitter base and other is called as collector base. That means in this case base will be common. Now symbols for NPN will be arrow on emitter pointing from base, and for PNP it is arrow on emitter pointing into the base. Now working principle is a small base current controls a larger collector current. For NPN transistor, the forward active mode, in this case emitter base junction is forward biased and collector base junction is reverse biased. So electrons are injected from the emitter, then to the base and then to the collector. The modes of operation, we have active mode, emitter base junction is forward biased, collector base junction is reverse biased, and this is used in application for amplification. Then we have a saturation mode. Under this, emitter base junction is forward biased, collector base junction is also forward biased, and it is used for switching on applications. Cutoff region, in this emitter base junction is reverse biased, collector base junction is reverse biased, and its application is switch off in electronic circuits. Then reverse active, under this case emitter base junction is reverse biased, collector base junction is forward biased, and this type of mode of operation is rarely used. Now coming on to the bipolar junction transistor configurations, we have common emitter configuration. In this, the input terminal is base of the BJT, output terminal is collector, and common terminal is emitter. The gain of this particular configuration is high voltage and high current gain. The second configuration is common base. In this, the input terminal is emitter, output terminal is collector, and common terminal is base. Here the gain is high voltage gain for voltage and low current gain. And last is common collector. In this, the input terminal is base, output terminal is emitter, and common terminal is collector. In this, the voltage gain is nearly 1 and high current gain. The current components and their relations. The Kirchhoff's law is applied to BJT. So emitter current IE will be equal to the sum of base current IB plus collector current IC. Common emitter current gain, that is beta, it is the ratio of collector current to base current, and typically its value varies from 20 to 200. Now here we get the relationship IC is equal to beta into IB. The main characteristics are input characteristics between base current and base emitter voltage like a diode curve, and output characteristics between collector current and collector emitter voltage for different IV values. Basically, the operation is active, saturation and cutoff regions. Now coming on to the applications of BJT, we have number one, amplifier, that is audio radio frequency operational amplifiers. Then it is used in switches, that is digital logic power control, oscillators and wave generators, current mirrors and voltage regulators. Thank you.